now going to touch the pad. Everybody in the world fused. Yeah. Morning crew, and welcome back to the Andy Mechanic YouTube channel. And I must admit, it's really nice to be back in my workshop again. I've been away in the South Island for most of the week, and then yesterday I had to flick down to Taupo, the batch. But here I am, it's Sunday morning. I was out nice and early and I set up a test rig so that I can test this Projecta Voltage Stabiliser. Well, that's one of the functions on it anyway. It's there's the model there, look. So it's a HDBM 4000, and this is the third video in this sort of investigation, and I never really intended to get this involved, but I got contacted earlier in the week by Projecta over in Australia, following up on some of the information that I'd submitted, and I sent them, you know, all the stuff that I gathered up in the last couple of videos and some PicoScope files and bits and pieces, and said, look, you know, what do you think? Is this doing what it's supposed to do, or is it not doing what it's supposed to do? And they went, well, I'll tell you what, before we answer that, would you do some more testing since you've got the scope? I said, well, yeah, no worries. I am really busy and I'll try and fit it in, and hence I need to get it done today, otherwise it's not going to happen for another few weeks. And I've got another ROV outside, and well, actually two outside at the moment that need repairing. Quite a lot of work to do, so I thought I'll get this out of the way first of all this morning. 3 hours later, I'm still here. My day is quickly slipping away. So what they said to me was, hey, you know, using a starter motor, it's not really ideal as a load on the circuit, and to get the projector to react to that load, because when you first start a motor, as we saw on the scope readings, it was over 200 amps of draw. So I said, okay, no worries, we'll use some halogen bulbs. And they said, perfect, halogen bulbs, brilliant. And if you can increment the draw rather than bang it all on at once, if you've got a number of different bulbs, energize one at a time, you know, so you've got one, and then you've got, you know, one plus another one, and then plus another one, and so on, up until the maximum amperage draw. Now, I also found out from the techs when I spoke to them that the 70 amp output that this tool is capable of is only available during the engine cranking function. It's not available during the diagnostic function. So we're back down to the original 40 amps maximum output during within the diagnostic function on the tool. So, you know, putting that starter motor on there at 65 amps, even once it had sort of settled down after a split second and the engine has started to turn over, was still an excessive load to have expected this tool to have coped with. So, hey, fair enough. You know, I just want to make sure that it's going to do what I want it to do. Now, I've had a few viewers' comments as well regarding volt drop and so on. There's lots to go through. If you're interested, read the comments on the previous video. There's a lot of stuff in there, a lot of very technical stuff, which I haven't got time to go into. However, I will point out that whatever the load is, regardless of volt drop within the load circuit, it's still a load. You know, I don't think it makes much difference. Sure, the Projecta tool has got some quite long cables on it, and they're not double cables. It's not able to sense the voltage at the end of the cables because there isn't separate wires or short wires. And the longer you wire, the longer your volt drop. You know that, and especially when there's more current flow. The higher the current flow, the greater the volt drop. So that's why we fit big wires to starter motors and stuff. So maybe, you know, there is a bit of a mix match in what the actual true voltage is at the battery compared to what the Projecta is actually reading it as. I didn't design the tool, and is that my problem? No. This tool is designed to have long leads so that you can mount the voltage stabilizer on the wall of the workshop or on a trolley or whatever, and then just run the leads over to the car. You can actually buy 10-meter long accessory leads for this tool. So that means that the circuit is 20 meters long. That's going to create a phenomenal volt drop and, you know, could exacerbate the problem. So what do I want to do? Well, I want to do a few things on this video very quickly. I really ramble on, I know, but I've been thinking about this quite a bit. Obviously, I'm going to measure battery voltage with the scope, and the scope will be connected to the battery terminals. I've got 2 amp clamps that will work with the scope. So we're going to measure the output of the projector current to see what it's actually giving out, and is that going to match what's on the screen on the display saying it's giving out. And we're also going to measure the actual current draw of the bulbs, the load, so to speak. And if there's much of a difference, then we can be pretty sure that any discrepancy or any shortfall of output current from the voltage stabilizer will be made up by the battery. The battery is basically topping it up so all the bulbs can light up, you know, and nice and bright. So, without further ado, before I get overcomplicated and forget what I'm trying to do, we will head back over. I've got the laptop set up, the scope's all on, the screen capture software's, you know, ready to go as well. We've got the rig. I think what I'll do first of all is I'll do a little flyby, like an X-Wing fighter, over the rig so you can actually see exactly what's going on, because I know some people are very, very critical about things like connections, because they can be points of high resistance and they can throw your tests way out. One last thing. Somebody said to me, hey Andy, you've got the projector, the voltage stabilizer, plugged in to one of those multi-plug blocks. That could cause a reduction in supply. So the projector's not getting the current flow it needs. Okay, right. I have a MIG. It's a 185 amp MIG, single phase, and it runs on the same circuitry within this workshop. Now, sure, I don't run it through that particular multiboard, but it does run through sometimes, if I'm on a lower setting, a multiboard, believe it or not. And it works fine. You can tell that you're down a bit on power when you're welding, but that's a huge current draw in comparison to what this projector is going to be pulling. Also, that may be the case in a workshop. You know, there's the actual sockets on the walls around the workshop may be too far away from where you want to use this tool, especially if you haven't got those 10-meter long cables. A workshop would probably be using an extension lead anyway. So, you know, you've got to take all that into account. There's nothing in the instructions that says, hey, make sure you plug it in directly onto a socket within the ring main of your workshop. It doesn't say that anywhere. So I'm just using the tool, you know, the way that I expect it will be used in a workshop. Okay, let's do a quick flyby across all the equipment and then we'll begin the testing. I don't think it'll take too long. I've currently got the car battery rigged up. That's one out of the MR2. It's a Bosch something or other. Details are on the last video. Now, my concern is that the majority of ECU reprogramming I do is on motorcycles. So once we've done this test on the car battery, I'm going to change it for a motorcycle battery, and then we'll see how that copes. Okay, here we go. Look, that's the infamous power supply. Well, not power supply, it's the multi-board. It's got a pretty hefty cable running to it, so I'm not too concerned about that. Right, so over here, we've got the Bosch car battery, and we've got the projector. These are the leads that come from the voltage stabilizer, and they're straight onto these battery clamps that I've put on. They're clamped up nice and tight to the terminals. So I'm pretty sure that there's a very good connection there. This is the kind of connection that you would get using the tool. So I'm just using what they gave me, and that's what will be, you know, what will be happening in a workshop. Okay, we've also got here, this is the pickup for the scope for voltage, positive and negative, again clamped, you know, straight onto some pretty hefty bolt on there. So I'm quite happy with that. Now, the wires for the load, this is the positive wire. We've also got an amp clamp on there, look, measuring that load when we start using it. That goes to a nice steel bracket, which we're going to put some, well, some fly leads onto each bulb. And these are the bulbs. Look at that. It's fantastic, isn't it? Now, one side of the bulb, there's no point in saying positive or negative because it makes no difference apart from that one. All these bulbs, one of the terminals is clamped between the wood and this old ruler. And obviously, you know, good connection, nice and tight. And I've put some plastic over the top, so when I put the crocodile clip on the top here, it's not going to potentially short, because we don't like fire. Fire's bad. And I ran out of these single filament 55 watt bulbs. In fact, what are they? Let's have a little look. Here's the box. Right, so these are all the way from England, and there you go. Look, 12 volt, 55 watt H7s. That's what my car uses actually on the dip beam. And then we've got one of these going on just to get the current flow up. And I'm going to be energizing both filaments at once. So one filament is 60 watts, the other is 55. Doesn't really matter because we've got the old amp clamp here, look, and the scope measuring the actual current draw. So we don't really need to calculate it, you know. Okay, so my intention is to set the camera up so you can see these bulbs being energized one at a time along here, and you'll get a good view of the screen on the projector. And it's currently in diagnostic mode at the moment, and it's charging up the battery. Wonderful. Okay, moving across, right, and of course we've got the laptop with the old PicoScope software all fired up. There's the scope, and we've got one more amp clamp down here, which is basically measuring the current flow from the projector into or onto this terminal here. Now, you know, potentially it could, I suppose, go into the battery. If the load was very low and the battery was drained, then the projector would be putting some current, you know, some charge back in the battery. But this battery is fully charged. Okay, right, there you go, the rig. Geez, things I do for you guys. Honestly. Okay, so without further ado, let's make some brightness with the bulbs and measure how that voltage stabilizer copes with an increasing load. And I'm just going to be energizing one bulb, you know, obviously start off with one bulb, and we'll ultimately end up with all the filaments being illuminated. So that should be around about 40 amps draw, but it won't just be a sudden 40 amps, it's going to be an incremented draw. Okay, here we go. Okay, so battery fully charged, it's sat about 13.9. The actual voltage stabilizer is not currently kicking out any amps. It's on full output should we need it, that's the 40 amps maximum, and it's set to 14 volts desired voltage, so it is a little bit below at the moment. Okay, we're going to start the scope. There we go. Hopefully we're going to have enough slides to record all of this. I've got to work pretty quick. That's one filament. Two filaments. So it's now fired up its internal fan to keep things cool. These ones are a bit easier. Okay. Now obviously you're going to get a bit of glare on the old screen. That really can't be helped given what we're doing. Four more to go. Hopefully we're not going to run out of time. So you can see now it's kicking out about 28 amps, 29 amps on the screen. Alright, one more to go. Let's put that on there, look, that'll work. That's one. Okay, so currently we've got coming out of the voltage stabilizer about 36.7, 37 amps. It's actually slowly climbing. So we'll see if it actually gets to its full potential of 40 amps. Right, I'm going to stop the scope. I'll stop on there. Now I want to save that before I lose it, so save as. No, it's not really a car, so we'll just put projector testing. Episode 3, really, wasn't it? Okay, save that. Right. Car battery. Cool. Wonderful. Okay, so we can also see very easily that our desired voltage, which should be 14 volts, is now 12.8. Right, so I think what we should also do whilst it's running is we should take another reading on the scope as I disconnect each of the bulbs, just to see, and I can do that much quicker, and we can just to see how that actually changes the waveform and the output from the stabilizer. Okay, so we're just going to play that again. Come on, scope, you can do it. There we go. Right, so disconnect these one at a time. Fantastic. Right, let's take a look and see what we got. Okay, we'll just stop the scope. And I want to save that one as well. So file, save as. Okay, and that's bulbs. Load reducing. Bulbs being disconnected. Okay, so I think it'll be that one there. Car battery, reducing, load. Brilliant. I always forget to save stuff. Okay, now first of all I want to go back and open the file where we were actually doing the testing of applying the load. So we'll go file, file open, and it will be that one. Okay, let's go back to the first screen. Okay, I don't think much happened on the first screen, so we'll just move forward. Screen 2. Here we go. Right, interesting stuff. So what have we got? Well, let's have a little look. Let's just zoom in. Seems to be, maybe I broke contact connecting the first bulb. No, me? Most likely I did. Alright, so this is the first bulb contact, and our voltage, if I can grab hold of one of those, at the point it makes contact, our voltage does drop to about 13.68, and you'll be able to see all of this on the video watching the actual projector, assuming that their scale, their voltmeter on the screen is accurate. Now this is the red trace, which is channel B, and channel B is the output from the projector. So you can see here, look, the output was very low, and 10 milliamps is the, sorry, by fault, 10 millivolts is the equivalent to 1 amp. So if we grab our little measurer there, look, stick it down here, initially over here on the red we've got, well, essentially no output from that tool whatsoever, and then it starts to give us some output because the first bulb, you know, the initial load has been applied, and it's giving us around about, so we're on the red trace, 60 millivolts, and we know it's 10 millivolts per amp, so it's giving out about 6 amps of current. Now we can also look at the draw on the circuit, and that's going to be the green trace. So obviously we have an initial spike, and then it starts to settle down. So if we take a reading around here where that's giving out maximum, in fact we need to zoom in a little bit because it's pretty inaccurate as this, isn't it? Let's have a little look. Okay, let's accurify. There we go. So we've got on there 47.5, so that's 4.7 amps of draw at that point in time, and the projector's giving out 6 amps. Okay, well that sounds pretty good. It's obviously putting a little bit back in the battery as well, probably because it was a little bit slow to react when I first connected the bulb. So here we go, let you see. That's our actual draw down there, me connecting the bulb, and it's sparking a little bit, so the connection breaks at that point. And the projector sort of, you know, there's a little bit of a delay. That's when the bulb first connects. In fact, we can measure that. Let's have a little look. So the initial connection is there. In fact, we can zoom in again. Let's be accurate. Okay, move that. What a Sunday morning job this is. Okay, so we connect it there, and then the projector really doesn't start to, it doesn't really start to react. It does actually, it reacts. I won't even bother measuring it. It does actually start to react straight away. If you look here, you can see that line is starting to come up, and that is the output from the voltage stabiliser. Then it goes into overdrive, and it really starts to kick out. So it does take a little bit of time. It doesn't really achieve or match. In fact, we can work that out as well. So if we can match the output draw, which was about 4 odd amps, wasn't it? So about there. So where that intersects, we can measure that again time-wise. So if we get that to about there, that's about 1.6 seconds. Yeah, that's what we found before, wasn't it? When we were doing the starter motor stuff, about 1.5 seconds to react, to give full output. Okay, right. Let's move forward and see if we can find the second bulb connection. Okay, I'll just close that. This is page 3. Ooh, man, it's all over the place now. Look. So again, I've obviously been connecting it, and it's been sparking. That's quite a bad connection, isn't it? Really, on the load. Okay, voltage stabiliser is getting very confused. Initial connection, it spikes right up. And then finally the load is connected properly, the second bulb. And you can see that the current flow spikes and then starts to come down. Okay, I mean, I'm not too concerned about the low level load. I would expect it to be able to cope with that, but it's interesting to see how quickly it can react again. You can see there, look. Don't quite know why it sort of gave up at this point and then tried again. Very strange. So it was increasing its output, was the voltage stabiliser. It peaked, and then it very quickly gets drawn back down. There's a lot of jumping around, isn't there? Okay, so that's the second bulb. Let's move on and see if we can find the third bulb. Okay, nothing happened on that screen because we're not zoomed in. There we go. Okay, so this is the third filament, should I say, that was connected. And again, bit of a spark, bit of a misconnection going on. And you can see the projector starts to recover. Okay, I mean, ultimately what we're looking at is this tool able to give out the 40 amps, and how long does it take to react? Okay, another filament there. Look, voltage is dropping. So we'll go to the next screen. It's getting pretty windy outside. And I just want to have a quick look at this. You see, that projector. Wow. That's quite a varying output, isn't it? Let's have a measure of that, see where we are with that. Okay, so maximum current out is about, where are we? Measuring the red, 47 millivolts, so that's 4.7 amps, which is quite low, considering there's about 3 or 4 bulbs connected now. And minimum, oh, hang on, am I measuring the right place? No, maybe I'm not. Sorry, my fault. Right, so we've got a maximum of 141, so that's 14 amps, that's more like it. And then we'll use this one down here, look. Okay, and that one is 162, so 16 amps. So between 16 and 26 amps is what the voltage stabiliser is giving out, but it is fluctuating between those two values. Interesting. Okay, we'll just zoom back out again. Oh wow, what the hell's going on here? Okay, so we have a nice clean connection of a bulb. There's your additional load, and of course it does spike when you first connect. And if we look at this, this is pretty good. Okay, so we've got yet again another volt drop. So we're currently, once that bulb's connected, we're running around about, try and put it somewhere in the middle, blue, 13.43 volts. So we're still below the desired 14 volts, but it's not, it's half a volt down, isn't it? And you can see once that bulb there, that filament is connected, then the voltage stabilizer really goes into overdrive, and that variation between maximum and minimum amperage output really does start to build, doesn't it? Just see how far apart that is. Okay, so we've got about 276 millivolts, which is 27.6 amps peak output, and that then drops down to 14.7 amps minimum. Jeez. Okay. Right, let's look at the next one. Again, poor connection, but you can see it does, in general, it does step up its output again. We can see that. We'll just generalize from now on. Let's move along again. Nothing on that page. Okay, so look at that one. Okay, so we've got the connection. Again, it seems that it's a poor connection. It does seem to break and then re-establish again. My fault. Don't know why I'm doing that so much. And as regards output, it has increased. Look, you see the markers are below again, and it does. It does react pretty quick. If you look at that, we've got the bulb being connected, and then we've got that. Obviously, the output of the tool has reacted to that. So let's have a little measure of that and see how quickly it does that, because that's really what we're looking for with this tool, isn't it? Okay, where's my little timelines? There's one. So that's when the bulb was connected initially, just there. And I've just got to find another one of my little timelines now. There we are. And well, we can't tell, but there's the first peak, and that peak has increased. So that has taken the tool 727 milliseconds. Sorry, hang on. Misreading as always. 6 milliseconds, that's more like it. So it's taken it 6 milliseconds maximum to react to that increased load. I think that's pretty good, actually. Okay, let's zoom out of that one. Just keep going. And again, you can see a little spike going on there out of the stabilizer because the load's increased. But we do see the voltage just coming down and down and down. So if we zoom in on the old voltage, let's see what we're at now. Right, in fact, let's zoom in after that bulb was connected. So, during, there we are, look, that's the bulb connection there. Initial volt drop, and the voltage, I'll try and choose an average somewhere. I presume put marker on there. You can see there's the center of that before the bulb, and you can see that that's too high now. It should be a little bit lower. So the voltage is still dropping, and we'll see that on the video. Okay. Right, let's skip right to the end and see what it's doing at maximum load. Right, another bulb. Okay, so if we go back, that must be the last bulb that we connected. Let's go back one more screen. Okay. Alright, so last bulb. Stick that in there. Okay. So again, it was a bit of a mix match. Didn't fully connect properly, but we can still work this one out. So we've got a load applied of 416 millivolts, which is 41.6 amps of load. We've got the voltage stabilizer giving out between 431 millivolts, that's 43 amps maximum, and minimum is 23.5 amps. So if you were to sort of take the average of that, that's what you're going to be getting as a charge. So we can have a quick estimation of that without using a calculator. Somewhere in the middle, we've got 33.5. So there is definitely a shortfall. 41 amps load and 33.5 amps coming out of the voltage stabilizer. Okay, right, let's have a quick look at, oh, it's not working. Have a quick look at when we disconnected the bulbs. That'll be, man, I missed a mouse. Stop me. Right, so we'll open the next one. Open. And that one, that was the reducing load one. But that would all happen much quicker in time because it didn't take long to disconnect them. Right. There we go. So we're starting on page 1. We've got maximum load, which if we just zoom in on there and measure that, it should be about 40 odd amps, I would say. Yeah, okay, 39, well, yeah, near as damn it 40 amps. We're pretty much bang on with our load there. Okay, let's just zoom out. And we can see our load dropping as I disconnect each bulb. And we should see, if I just scan through the pages, the voltage start to increase. So voltage under maximum load, let's have a quick check of that. Here we go, look, about there, 12.5 volts. So actually very similar to what we saw with the starter motor, believe it or not. So we're still seeing a 1.5 volt discrepancy between what we've desired the tool to give us, 14 volts, and what it's actually giving us as, or maintaining the voltage at that battery to be, which is, in my opinion, nowhere near good enough. Okay, let's just close that, and we'll just flick through the pages, and we should see the voltage, the blue line, start to increase, and we should see the current out of the voltage stabilizer reducing, and of course the actual load reducing too. So as we flick through, look, you can see everything's, the voltage is going up, the blue line should be going up, and the other two should be coming down. I think that's it. Cool, right, back to the bench. Cold coffee, yummy. Just had 2 bacon butties. Yes, very nice. Gotta have bacon on a Sunday, haven't you? Now, that really sort of highlighted the same kind of problems we had using the starter motor. We've got a desired or required voltage. We've set the voltage stabilizer up to be 14 volts, and I just watched the video back of that testing, and there also seems to be a discrepancy between what the projector's showing on its screen as the voltage and what the scope is telling us the voltage is. And believe me, I believe the scope and not what's on the screen on the voltage stabilizer. The scope we saw under maximum load, the voltage was down to 12.5. On the projector, it was telling us 12.9. That's nearly half a volt discrepancy. Almost, hiding the severity of the problem. So that's all down to projector to come back and tell me what's really going on and, well, their response, I suppose. Okay, so the next job, we've tested a car battery which has got quite a large capacity. I do a lot of programming on various brands of motorcycles, and motorcycles have really small batteries usually, which means their capacity is a fraction of the car battery. Now, when the capacity is reduced and you put a load on, because the capacity is less, we should see a larger volt drop. Basically, everything is accentuated. So I'll change the rig, get rid of the car battery, plumb up the motorcycle battery, and we'll do a similar test. Right, let me finish my coffee, come back to you in a second. Okay, coffee's finished. I've installed the motorcycle battery, got rid of the car battery. I'm going to quickly show you the connections so you've got an idea of how it all works and what I've done, so you can comment if you feel the need, and we'll get some more results. Here we go. There is the battery, and we've got the scope pickup just here, look, on both sides onto the actual crimp terminal. There's not a lot of room because it's only a motorcycle battery. I've extended the terminals with these bolts, and we've got the projector connections just here, look. And of course it's raining really hard, so you can hardly hear me. Okay, right, we'll just tilt the old projector back a bit again, like we did last time. And there we go. Let's get some results. Okay, I've been waiting for the rain to stop. I can't wait any longer, sorry. Let's just fire the old screen capture software up. Okay. Right. I'm going to start with scope. Scope's running, and we'll just start connecting up bulbs again. That's 2 filaments. 3, 4, 5, 6, 7, 8, 9. Right, one more to go. Don't know where the lead's gone. There he is. And the last one. Okay, now I'm just going to stop the scope. And just looking at that, we're still at 12.6 indicated on the screen, and it's giving a maximum of 39.9 amps output. So that's running at a maximum. The heat is fantastic. I might leave that on for a minute. Okay, let's head down to the scope and see what these results compare, or how these results compare to the car battery results. Okay, channel over range. Who's over range? Well, I still think we got what we needed, so we'll just go back. Okay, I want to save this first of all, so file, save as. Okay, motorcycle battery. Okay, and we'll do that one. Nope, increasing load, motorcycle battery. And I just want to include the part number of the battery so that they can, they know exactly what it is we're using. So it's a GTZ8V. GTZ8V, whatever that is. There we go. Save. Okay. So just scanning through the pages then. Page 1, not a lot going on. Page 2, we connected the first bulb. Again, it jumped a little bit on the connector. And you can see that the voltage stabiliser springs into life and suddenly increases its output. And it really sort of increases its output a lot more than it did with the car battery by the looks of it. And we had a pretty significant volt drop, so let's have a little look at that first of all and see how that was. Alright, so our initial voltage before we connected the bulb was around about, hang on a minute, which one are we reading? Yeah, second one, okay. So, yeah, 13.97, 14 volts, absolutely bang on the money. Okay, and initial drop, when we first connected the bulb, it dropped down to 12.98, so we lost basically a whole volt in volt drop as we connected that bulb. Okay. Right. This is really interesting. We've got what's going on with the current here? Look, it spikes right up and then it looks very little. Let's have a little look at that. That doesn't make any sense. Let's move our box. Okay, so current flow before we connected any bulbs was essentially with the amp clamp. I did zero the amp clamp. It seems a bit strange. because it's saying on there we've got minus 1.5 amps, and I haven't moved the orientation of the clamps, so they're connected correctly. Okay, and then after connecting the bulb, it's saying that we've got even less of a draw, a negative draw. That's really weird. I might have to redo this test. Okay, let's just see how that progresses in future slides. Ah, okay, there we go, look. That's more like it. Alright. Yeah, so the amp clamp's set up correctly, and I did zero it. So maybe I have to ignore that very first bulb being connected. Okay, so next one, we've got a very clear and clean connection of the second filament, and you can see that the projector takes quite some time to react. You can see the volt drop up here as well. Let's have a little measure of whatever that volt drop was. So if we put that one down there, look, we'll ignore the initial spike, we'll just go for the average. And before and after, so we had 12.39 volts initially, connected the bulb, and it dropped to 12.07. okay, let's just get rid of that. So that's that period just there, look. And then the voltage picks up because the current at the stabilizer is greatly increased, then it's decreased, so the voltage swings back down again, and then the stabilizer pops out some more current, and you can see the voltage now starts to stabilize correctly. And as it so happens, significantly higher than before we connected the bulb. Wow, what's going on there? Okay, so now once that bulb's been connected, we're seeing almost the 14 volts desired. Wow, okay, let's just go across a little bit. Yeah, near as damn it. If we just bang it in the middle of there, that's central. So we're getting 13.74. So it's still a quarter of a volt drop to what we've actually requested it to be, but still not too bad. Right, let's keep on trucking. Now you can see here again a very clean connection. Another bulb is connected. We see the projector instantly react with current flow, and we do see a reasonably significant volt drop again. And we should be seeing a larger volt drop than we would do with the car battery. Okay, so what do we see there? Look, we get a volt drop of 3/4 of a volt basically on there. Right, we'll get rid of the little box. Moving along. A bad connection there, look. And now we start to see the voltage stabilizer going into this sort of cycling mode here, look, where it's really kicking out quite a high current, and then it drops to a lower current again, like we saw on the car battery. And that's it, that's all the bulbs. Okay. Right, let's do, we've saved this capture, let's do another capture of me disconnecting all the bulbs and see how quickly the stabilizer reacts to a reduction in load. Okay, I'm just going to check I have saved it, so save. Okay, yes we did. Okay, right, so we'll start a new one now. Right, I've started the scope, here we go, disconnect time. Oh, getting quick at this, aren't we? Right, let's take a look. Scope is stopped. Okay, let's go back. There you go, that one's working again. That must have gone to sleep. Okay, so we should see our voltage increase as we disconnect each bulb. And you'll see here on the green trace, this is me disconnecting a bulb. And you can see that the voltage regulator, the stabilizer, is instantly reacting to that, we can see a drop in its output, bang on the same period of time that I'm disconnecting the bulb. And if we scroll up, we'll also see the equivalent step in voltage as the voltage increases. You can see they all basically line up. Okay, so what, oh look at that, it's fantastic, isn't it? Dum 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 dum, like dominoes. And you can see the voltage stabiliser reacting to the reduction in current draw. Very clean actually. Let's see what our maximum voltage was. Looks like it's going to be about there. Let's just go back one. Yeah, let's measure that. Okay, so we'll just put a little box down there. Move it right to the end. There we go. What do we get? What is the voltage? Okay, 13 volts. So it didn't actually spike over the maximum of the 14 that we commanded. So in actual fact, at no time during that whole period did the voltage ever get anywhere near the desired 14 volts that we asked for. Jeez. I'm wrong. No, I'm wrong. Let's do that again. I'm reading the wrong line. What an idiot. Okay, let's go back to that one. And it did. Sorry, my fault. 15.1 volts peak, which is about a volt, 1.1 volts over the commanded voltage. If I put this down to 14 volts to give us an idea, there we go, that's near enough. And we'll just flick through the pages, we can see that whilst there is a load, we are nowhere near the commanded voltage. It's just not able to keep it. Wow. Right then, crew, I'm back. Took quite a while to do all that testing, and believe it or not, I have already done a conclusion sort of video. The last bit of the rush is doing a sign-off, going through some of the data. And then when I was editing the video, I said, look, Andy, this isn't conclusive. It's not enough in depth. You've not really covered the data in any real depth. So a week's gone by, I'm here in the workshop all on my own, and I thought, right, let's get this finished. So I've done my little tables, and Ben was saying, why do you do a spreadsheet, Dad? And I says, no, I want to draw it on a piece of paper. That's just the way I work. Now, as you can see, there's quite a lot of information on there, and I've summarised the data for both the car battery test under increasing load and the motorcycle battery test, again, under increasing load. I've not done tables for the testing we did on decreasing load. You can work that one out for yourself if you like. I think this is a bit more relevant because there was more of a lag time in the tool reacting. Now, there's quite a lot of data on here, and I'm not too sure how I'm actually going to get this across to you. Let me have a little think. Yeah. I reckon I need a tool girl. Hang on a second. There you go! New tool girl!
Hello!
What's your name?
Lily. Tool girl Lily.
Come and say hello to the people, Lily.
Hey guys. Nice to meet you.
Wow. Where did you come from? I mean, I just clicked my fingers and ping, you're here.
Magic.
I did get one of those crackers and it said I had a wish, so maybe it came true, who knows. Alright Lily, you've got a job to do, by the looks of it. Can you potter over there, and I'm going to read out some numbers for you.
Cool.
And so I'm just going to basically pull some data from losing my words now. I can't believe that I've got a tool gun in the workshop. I wasn't really prepared for this. So I've selectively chosen various loads, they are look more technical now, various loads from the results that we got on the PicoScope. So initially, the first filament that we energized was bulb number 1. So Lily, can you write under bulb current, can you write 4.6 amps? So that'll be in that box there, look, and we're going to be working across here like this, the next one, so 4.6. Wonderful stuff. Cool. Make it as big and bold as you can so everybody can see what's going on. Feel free to double line it if you want while I'm going for the next one. And under 4.6 amps of load, that's one filament, we got a voltage of 13.94 volts. So pretty damn close to the 14 volts we asked for. So 13.94 tool Girl Lilli, if you don't mind. And the voltage stabilizer, the Projecta tool, gave out at that time, was giving out 4.2 amps. So that's your next box there, Lily. Cheers. So we've got a deficit of 0.4 of an amp. So we're using 4.6 amps and the tool's only giving out 4.2. So you've got a deficit of 0.4. Wow, she's bloody good. You can come back. Okay, so the next, I'm going to jump down to filament number 4 now. I'm going to stay out of the camera a bit so the lady's got a bit more of a shot and you can see the board. So bulb number 4 was drawing, the first 4 filaments were drawing 18.3 amps. So 18.3 amps on that one. And then our battery voltage got pulled down to 13.78. Are you keeping up with me? Is that all right?
Yes.
I'm not.
Yeah, no,
Tell me if I'm getting ahead of myself, wait, because it's a bit hard to see on the everything's sort of reversed on the camera. So 13.78 volts was our battery voltage with the 4 filaments energized, and the voltage stabilizer at that point was giving out 18 amps. So 18 amps for you. Oh, that's really good.
Wow,
Much better writing than mine. Okay, 18 amps was the draw, was the output from the voltage stabilizer, and the deficit was actually quite small at that point, 0.3 amps. So 0.3 amps of deficit, which means we're using 0.3 of an amp more with our consumers, the bulbs, than what the tool's giving out. So it's not bad, but the voltage is going down, isn't it? Okay, next one, Lily, is number 8. There we go, hang on. No, my fault. That should be a 3.
Oh, sorry.
I was getting ahead there. That's at 0.3. Just give it a...
Oh, no.
It's all right. It's live. We can cope with that.
I read it off your paper.
All right, so we've got 0.3. Perfect. Okay, so again, it's not too bad. I would say it's acceptable, but it's not too bad. Right, so for filament number 8, or bulb number 8, we're now drawing 34.1 amps. Quite a high load, isn't it? So 34.1 amps on there. And then our battery voltage is being pulled down to 13.27 volts. Starting to get a little bit significant, isn't it? Now, the voltage stabilizer at this point is giving out, as great as that, is giving out 27.15 amps. Substantially less. So 27.15 it was. You've got a good memory. I'm terrible with numbers. I have to keep writing things down all the time. And your voltage deficit, the difference is 6.9 amps. Nearly 7 amps. That's a lot. I'm not happy with that. You can tell I'm not happy, can't you, Lily? Yeah, I'm getting a bit grumpy because of this. But there's some good news at the end of it, don't worry. Okay, so 9 filaments is 37.7 amps.
37?
Yeah, 37.7. Fantastic. Well, mind yourself on that vice, won't you? All the hazards of my workshop.
All the hazards.
And your voltage has now dropped to 13.1. 13.1. It's only going down, isn't it?
Yeah.
It's not good.
Not good.
Okay. No, and the voltage stabilizer is giving out 31.67 amps.
31.67.
And the voltage, the amperage deficit is 6 amps. So 6 amps on there. We're nearly there, crew. Nearly there. Remember, this is the car battery, and with the car battery, we would expect to see less of a volt drop. So when we do the motorcycle battery, I think we're going to see some even more lively figures. Right, last line there, Tool Girl Lilli. So 41.3 amps was the draw with all 10 filaments, and if you remember, this was the rig. Oh God, we got Lily there. Look. This was the rig that we used. I've still got it, and I'm probably going to use it for something else in the future. Who knows? Pretty useful. So your voltage now has dropped to 12.92 volts within sort of the loom on this test rig. Now, the voltage stabiliser, this is its sort of final chance to prove itself as doing its job properly.
Come on.
Yeah, it hasn't though, has it? If you've seen the graphs on the bit earlier on and you've read them properly, then you'll know. 33.81 amps. So 33.81 amps, and that's a voltage deficit of 7.5 amps. That's beyond excusable in my book, to be perfectly honest. Now, you know, some of you mentioned about having really long leads and it can't sense the voltage and there's volt drop in the leads and stuff. Believe it or not, I don't care, because I bought the tool, connected the tool as it says in the instructions, turned it on, desired voltage 14 volts, and it's not doing it. How it achieves it is not, it's just irrelevant to me. You pay the money, it should do the work. Okay.
Pay for performance.
You do. I mean, it wasn't cheap. These things have got a retail value, I think, of about 1,300 New Zealand dollars. That's a significant chunk of money in anybody's book. You know, a lot of workshops are going to be considering, do we buy one, do we not buy one? You know, that kind of money. It's not a, oh yeah, just send it down. You've got to think about it, haven't you? So we can see on here, look, Lily, we've got obviously the current, as the current increases, we've got the voltage has dropped. Okay, we could say that 13.94 is pretty much on the money. We're still happy at that.
Yes.
But down to
Down here.
yeah, we're over a volt down on our voltage, which is,
Not good.
I don't think it's good. No, especially if you're programming a car. You know, cars have lots of ECUs or modules, and they require the voltage to stay very, very stable and certainly not drop this low. Going across as regards our current deficit, 7.5 amps. Nah, I'm not happy with that.
Disappointing.
I think you're even disappointed, aren't you?
Disappointing.
Yeah, it's not good. Not good at all. Okay, so that was the results, or the summary, or snippets of information from the car battery testing using the PicoScope. And yeah, Lily, you can hold on to that if you want. And the little test rig of bulbs. I'm going to have to disassemble it at some point because I'm going to run out of bulbs otherwise.
Might be able to give me a hand or two and teach me how to do that.
Absolutely. So don't forget, there's still more to go on this summary, but the information, the results, including the PicoScope files, I'll chuck into a Google Docs drive, and I'll put a link down the bottom of this video for you. Wow, you do look great on camera, you know.
Thank you.
Fantastic. I do like that. Okay, so let's now do a quick summary on the motorcycle battery. Yeah, the small one. And don't forget, the small battery's got a much, much smaller capacity, so it's not able to help top up the voltage as much as the car battery did. So we should see, I think, in theory, okay, I've seen the results already, but I would expect to see more of a volt drop.
Right.
Definitely. All right,
Let's find out.
grab my other very expensive
Awesome.
piece of cardboard. And we'll just get rid of those. Oh man, good. You've got strong hands. Right, you ready? Okay, let's go for it.
There we go.
Bloody good. Right, one pen.
Handy pen.
There I go.
Need that?
Easy.
Don't need the left.
Right, where's my notes? I've got to remember to stay out of shot here. Okay, here we go. Right, so where's the old one gone? Down there at 416, yeah, it's cool. Okay, so bulb number one, we'll try and be as quick as we can now. Bulb number one, 4.4 amps, obviously was the draw. Now there is some slight discrepancy. You might say, so, well, hang on a minute, Andy. Why is the voltage, or why is the current draw less than it was when you first energized the bulb with the car battery? Well, don't forget, the next result that I give you will probably explain that. Battery voltage is 12.69, significantly less than it was with the car battery. So bear that in mind. Okay, oh, you're doing well. Okay, right, moving on. So the voltage stabilizer was giving out, at this point in time, only 2.2 amps. Now, believe it or not, according to the PicoScope, that was a negative 2.2 amps. So the current, in theory, I don't know why, and I did zero the amp clamp, the current was flowing in the opposite direction, as if the voltage stabilizer was drawing a current. Don't understand why. That's what the Pico was saying, and the amp clamp was zeroed. Okay. Okay, so you've got minus 2.2 on there. And we also need that's right, that's cool, that'll work. Now, bulb number 4, things start to get a bit more sensible again now. Bulb number 4, 18.1 amps on there. And the battery voltage, believe it or not, is now higher. And the reason for this is because the voltage stabilizer has now kicked in and is giving an output, so that's why the voltage has picked up. 13.68 volts for that one, Lily. Cheers. And the voltage stabilizer is giving out, at that point in time, 17.46 amps. Still a little bit less than what we're consuming with the bulbs, but 17.46 amps, giving us a voltage deficit of 0.64. So about 0.6 of an amp down on what we're using with the bulbs. Right, I think we're on bulb and break now, aren't we? Yes. Okay, so once the 8th filament's energized, we're drawing 33.75 amps. And the battery voltage has plummeted to 12.88 volts. So it's really struggling now.
It's struggling.
It is. It's quite a lot lower than with the car battery, unfortunately. Voltage stabilizer's given out 29.87 amps.
0.87.
29.87, yeah. And the amperage deficit is 3.88 for your end column. Almost there, crew. Now, filament number 9, 37.1 amps. And the voltage now has dropped to 12.59.
5.9.
12.59 volts. Now the voltage stabilizer, the projector is giving out 32.87 amps, which according to my mathematics, and these were after a few whiskies last night, so forgive me if I've made a mistake, but it should be 4.4 amps of deficit. So essentially we're using about 37 amps with the bulbs, and the projector is giving out 32.68. So there's a shortfall, isn't there? Right, last line. We've got a maximum draw with all 10 filaments of 40.4 amps. That's 40.4 amps. Battery voltage has reached an all-time low. This is the lowest voltage reading in all of these tests of 12.24. Now don't forget, the desired voltage was 14 volts. I set this tool to 14 volts. It should be able to cope with the 40 amp load. That's in the instructions when it's under the diagnostic programming, and it hadn't managed to attain that. It was or stabilize that voltage. It dropped to 12.24, and it was only giving out 35.23 amps of current flow. So 35.23 amps there. And then in your last box, Lily, it wants to be 5.2 amps. So we're 5.2 amps short from the voltage stabilizer compared to what we're actually using with the load. Now, it's not rocket science. Where is that deficit coming from? That additional current required to run those lamps has to be coming from the batteries. And with a car battery, okay, it's a big battery. If it's fully charged, it's going to last a short time. But we did still see the volts drop, the voltage drop in the loom. With the motorcycle battery, that's going to be much, much faster. That voltage is going to drop off real quick. And when you're programming ECUs, it's really important that you keep the voltage, above a certain threshold, or at least, ideally around a set voltage. That's the whole reason for using a voltage stabilizer. If for any reason that voltage does drop too low, then it can actually interrupt the communication between your laptop or whatever device it is you're using to do the reprogramming and the vehicle's ECU. And if you're in the middle of uploading a file and that happens and you get a communication dropout, it can potentially render the ECU as junk.
My God.
No, and they're really expensive ECUs, And I mean, for me, I don't want to be paying out for a new ECU for the customer, because essentially it's my fault. I should have the equipment, the right equipment to do this job properly.
Absolutely.
And so what I did is, earlier in the week, since I filmed all the testing to today, because today is Sunday, believe it or not.
Test day Sundays.
Test day Sundays, that's right. Sunday mornings are great for testing.
Sunday mornings are good for all of us.
We can elaborate on that off camera if you like. Jeez, okay, you're getting me thinking now. I'm just going to have some more of my coffee and try and relax a little bit. Damn, Lily. What do you like? Okay, so I sent all this information through to Projecta earlier in the week. The Pico files, screenshots, summary email, giving them my findings and what I felt, you know, how to read the data, you know, what the data was telling us.
Really well tested.
Yeah, I thought so. I mean, I did what they asked me to do. They asked me to use, you know, bulbs as opposed to a starter motor, and to increment the load step by step rather than banging all, you know, the load on in one big hit. So I did everything they asked, and they came back to me. They were very, very quick to respond, actually, and I must admit, I give them full credit for that.
Yeah.
I've actually forgotten the guy's name over in Sheridan. I think it was Sheridan over in Australia. He gave me a call while I was at Nelson Airport last week, and he said, "Andy, I've just seen your email, and you know, the results that you found are very, very interesting indeed. Our engineers here are studying them closely. They did say that they may well decide to run some of their own tests to validate what I found. They obviously." They wouldn't admit the fact that the tool wasn't fit for purpose. And I wasn't really asking them to do that. Essentially, I just wanted them to say, look, this tool, in my opinion, isn't suitable for what I need to use it for. You know, and I reprogram motorcycles most of the time, and that's where we saw the largest volt drops going on. So I said, look, tell you what, we'll do one of two things for you. We'll either send you, we'll upgrade your voltage stabilizer to our sort of top-end unit, I forget the model name, substantially more money, or we'll give you a refund for the one that you've got. And I said, look, I'd say the best thing to do for now, until I want to do some more research into the different products available, do me a refund. I'll drop it back off at the suppliers in Auckland, sort me a refund out, and then I'll be back in contact if I feel that the other tool that you've got, you know, once I've read the specs, is going to be suitable for what I want to do.
Yeah, absolutely.
And he said, no worries, perfect. Really appreciate all the testing you've done. So everything was very proactive, which was really nice to get.
Professionally dealt with.
Yes. I mean, let's face it, you know, the sale of one of these tools for them is almost insignificant,
right.
really, because they're going to sell so many anyway.
Yes.
They're a big company, they import all sorts of stuff. So it's very important is their customer service, that their customers are happy. And in reality,
So that feedback is quite huge.
yeah, and I wasn't happy, but I think I've justified my reasoning behind it.
Absolutely. No, totally.
Yeah. Okay, so like I said earlier on, I'll put a link to a Google Drive folder with all this information in there. It'll have all the I think some of all the PicoScope files from previous testings are already there. I'll upload the new files, other bits and pieces. I might, if I get time, I might even drop these into like an Excel spreadsheet thing, and I don't know, drop those in there for you as well. Either that, or if I run out of time, I'll just take pictures of these for you. Pictures will work. You can see all my scribblings and workings out. And feel free to mark it. You know, give me a mark out of 10 because there might be some you know, mathematical errors in there.
Feedback is great.
Blame the Jack Daniels, I reckon. It was a long night last night. It sure was. And Lily, you're in. You're here.
It's awesome.
I just click
nice
my
to be
fingers
here.
and
Thank
ping
you.
And
it's great.
You've been very, very good doing
Writing
that.
the numbers.
I think we should have you back.
I would
actually.
love to be back.
So there's
It would be great.
There's a place under the house for you.
Right.
The other tool girls, this is all a secret. So only
Store me there.
only
Grab
people
me
that
out
watch the
when you
channel
need
know
me.
about this.
Cool.
From now on, I sell your car on trade me. You live under the house, and when I need you, I just.
Decent car. I hope you get some good.
Well, you know.
Something decent out of that.
It'll
Cool.
Okay.
All right. Well, it's been great to be here. Thank you for having me.
Absolutely,
And
and
it's been awesome.
thanks for dropping by. It's
Awesome being
you
your
arrived.
assistant for the day.
You arrived just at the right time. It was
That's
perfect. You just click your fingers, ping. There you go. You know,
There she is. She's here.
bloody good. You must have known, I reckon.
I had
Yeah,
it.
you must have known. And I do get tool girls just rocking up. They just turn up saying, "Hey, can I help you for today?"
It's the place to be.
It's starting to happen.
It's the place to be.
They don't even ring me up or send me a
Just
text.
turn up.
They just turn up.
We don't
and
even
say,
send a text. We just turn up.
I'm here to help, Andy.
We're not
You-
sending no
you
text.
need
We're
me,
just turning
you know?
up.
Yeah. Okay, crew. Well,
All right.
if you enjoy this video, why not click on the subscribe button? You'll see a little gear icon turn up. Click on the gear icon, and then you can tick the box and turn on notifications. And our friends down at YouTube, well, they're going to send you an email as and when I upload any new videos. And there's usually 3 or 4 a week. I know I've been a bit thin on the ground the last week, but I've been away and there were delays in getting this video out to you because I wanted to be a bit more conclusive about my findings, and hopefully you respect that.
That's awesome.
Yeah. Now you'll also find me on
Facebook, Instagram, Google+, and Twitter.
You sure will. Feel free to communicate through any of those portals, chaps. Oh, and chapettes, of course. But first point of contact, if you don't mind, through the comments on YouTube, because that's where the videos are and that's where I am most of the time. Not always. I do have a life. I do other things. I go to the pub and I have a job and, you know, other stuff.
Thanks.
I even watch TV every now and again, but most of my life is spent making videos or editing them, to be honest, or being at work.
Or reviewing your comments.
I do, yeah, every now and again. I'm pretty crap at that recently. I just
really?
I just haven't had time.
It's important.
It is important. I just need to put a PC under the house, plug it into the internet, and let the tool girls do it.
Yeah, I was going to say.
Yeah, that would
sounds
make
like a
life
tool girl's job then here.
There you go. Deal with
the
that.
charger.
Pretend that you're me, and don't say dumb shit.
Yeah.
You know. But no. I will. I'll get back to it. I promise. Now there is also, don't forget, a Patreon page. Now on the Patreon page, it's been up for maybe, I don't know, 3 or 4 months now. You'll find information about the history of the Andy Mechanic YouTube channel, how it came to be, and it was a little bit by accident, to be honest. It wasn't really planned. It just
Bright idea.
just sort of happened. Yeah,
Bright
evolved
idea
very,
that
very
came to
quickly
life.
and took over my life, and now I have nothing else to do.
Sounds
Seriously.
like fun.
It is, actually. But, you know, it's a lot more fun having you here, Lily, than
Absolutely.
being in front of the camera on my own.
Learn
Believe
lots.
me,
You learn lots.
You know, I do
And you
enjoy
get things done.
I do enjoy company. I do, definitely.
It's good to be here.
Now, where were we? We've done Patreon, yes. So you'll also find information about the history, up and coming projects, and there are profiles on there of each of the tool girls. So Lily, you're going to be on there too.
Hello.
You are. Tool
Find
Girl
me
Lily's
there.
profile will be uploaded in the next couple of weeks, I'm sure. So you can have a read all about that. And
me there.
maybe I'll give you a little bit of a clue as to, well, why she's here, basically. Who knows?
What do I do? Who am I? Soon to find out.
That's right. Yeah. Now, don't forget, with Patreon, you can become a patron and you can donate to the channel if you like. We've got a handful of patrons now. It's slowly growing, which is great to see. If you do decide to make a donation, please only make a donation amount to what you can afford. It's, you know, don't donate more and cause yourself problems. You know, if you don't want to donate, it's not a problem at all. Most people don't. But if you want to send a little bit through to help the channel, then it's much, much appreciated. And you will get a mention at some point in one of the future mail call videos. You haven't done a mail call video, have you?
No, I haven't.
Okay,
Forward to being part of that
we'll
too.
put your name down for that for sure. It'd be great fun. Okay, crew.
Awesome.
Well, it's signing off time, so it's goodbye from me, Andy Mechanic, and it's
Been
goodbye.
Nice to meet you guys. Lily Steele, Tool Girl Lily.
Oh, very nice.
Lily
Yeah.
Steele is my artist name, so I thought I'd
Artist.
introduce
That's
my
why you
full
make it so
artist
good,
name.
eh? Yeah, there you go. Perfect.
It's been great meeting you guys.
Okay, crew. Until next time, we'll see you around. Cheers. Over and out. Good job, Lily. You're getting the hang of this, aren't you?
Thank you. Slowly.
And we get the flip again.
Oh!
Really.